Hello, everyone. My name is Tanvir Ahmed. As Diane mentioned, I'm a PM on the Windows team for mobile device management. And today I'd like to talk about a couple of things. First, just go over what MDM or EMM is, do a brief overview of that and how it came about, what the market looks like. And then I'd like to kind of dig in deeper and go into, what does it take to actually build an MDM server? Like what does that process look like? How do you register a device or enroll a device? How do you manage devices? And dive in a little bit deeper into that. This space kind of deals with two primary protocols. There's MSMD2, which deals with registering devices with MDM. And then there's MSMDM, which deals with once the device is enrolled, how do you manage the device, or what does the life cycle of that device look like? So there's two protocols, and they kind of deal with different aspects of MDM. So what is mobile device management? So MDM or EMM is really just an industry term that's used to kind of describe how an enterprise or organization manages devices in their estate. It's a protocol that allows you to push down security or productivity policies or apps or resources onto your device, and so that it allows users to be productive and use their devices. At the same time, it also allows IT admins to ensure that the devices are secure and that they're not going to compromise the organization's network. It's because, like all web services, right? It has to do with a client component and a server component. Now, for MDM, there are MDM servers, which are third-party servers not built into Windows. But Microsoft does have an offering, and I'll touch on that. And there are client-based components as well. So Windows has a built-in client that implements the MDM protocol, and other platforms like Android, iOS, Macs, BlackBerry, they also implement their own versions of the MDM protocol, and they also have clients on their platforms that implement MDM. For servers, we have products like AirWatch, MobileIron, Intune, BlackBerry, SOTI, Good, a lot of folks. And these are all just management servers that also implement MDM. So what does this generally look like? Well, a client effectively registers itself with an MDM server, and then the MDM server pushes down configurations onto the device. And if we kind of look at like how MDM kind of came about, it really started back in the day, up until 2010, BlackBerry essentially was king in this space, right? So they had this MDM server, BlackBerry server, that used to push down MDM policies onto effectively just BlackBerry devices, right? So they owned the server and the client components of this, and they had like a 43% market share. It was really just BlackBerry. And MDM kind of came out of this thing called the OMA standard, the Open Mobile Alliance standard. And what this standard was, we've actually seen it in one way or another. The Open Mobile Alliance is just an organization built with mobile operators, device manufacturers, IoT companies, and they've kind of come together and built this general standard of how do we communicate to our devices and set things up like, for example, if you take a AT&T or T-Mobile SIM card and put it onto your device, how does that device actually know how to talk to T-Mobile or AT&T's network, right? There's a lot of little things that happen over the wire to get that device set up. Those kinds of communications are built on this thing called the OMA standard, and MDM kind of was built on top of that OMA standard. It was assumed that we already have a way to communicate with mobile devices, so why not actually build this MDM platform on top of that existing communication channel? And all of that roughly changed in 2010, like most of the rest of the mobile industry, when iOS came out, and with iOS 4, they added MDM support. Now all of a sudden you have this popular smartphone that implements MDM, and with the introduction of the iPhone implementing MDM, you have MDM servers, in addition to BlackBerry, start coming into the market. So we have players like AirWatch and Good kind of come in, and they're also offering MDM servers. Shortly after iOS, Windows Phone 8 became the first Microsoft offering that implemented MDM, so you can manage Windows Phone 8 devices with MDM. And Intune, Microsoft's MDM offering, was released somewhere around this time. And then as we go down, there's more MDM servers that kind of come up. Up until 2015, which is kind of the last defining moment where we see the current landscape that we see today, where Windows 10 broadly announced support for MDM across all devices. So for Windows, if you look at phone, desktop, Surface Hub, HoloLens, IoT, pretty much every Windows device that we ship today has a built-in MDM client. So all these devices are now manageable with MDM. And you have Android for Work launched around this time as well. And you have more and more MDM servers that kind of make up the current market today. And the market's growing, right? This is slightly old data, but it's really trying to emphasize that the market is growing at an exponential rate. And generally, as you can see, like because Microsoft has put in this MDM client in all of its all form factors and all devices, we're also taking a bet that this is the future of management. So, kind of now that we have like a very high-level view of how MDM works or how the market came about or what it actually does, let's kind of dig in a little bit deeper and then go into the individual protocols and go into like how this actually works, right? So I, as a user, I have a device and I want to use my device for work. Let's say I just joined a new organization. At Microsoft, we like to use Contoso. So let's say I, as a user, just joined Contoso and I want to use my device on the network. Well, there's an IT admin at Contoso, and what the IT admin does is they want to make sure that the device is secure. And so this random device that I want to bring on the network, the IT admin's responsibility is now to make sure that the device is secure, it's not compromised, and it's actually able to get onto the network. And even once you're on the network, how do I make sure that you have Office or you have the right apps or policies to do what you need to do? Well, the way this works is I take my device and I enroll it against my organization's MDM server. This is similar to domain joining a device today, right? So all we're doing at this point is just registering the user's device with the organization's MDM. Once we have this registered, what happens is the MDM server sees that you have this device. It looks at the information that we've passed up to it, and then it pushes back a bunch of productivity and security configurations onto the device. These can be apps, these can be VPN profiles, corporate network certificates, what have you. And these are passed using a special format called MDM SyncML. So SyncML is really just a fancy way of saying specially formatted XML. But this is what came out of the OMA standard. So they decided that having these lightweight XML files or XML payloads was the way to kind of configure very quickly these mobile devices in the past, and that's what's kind of carried forward with the MDM protocol. So you have these MDM servers that you have the devices registered with the MDM server. The MDM server pushes back configuration profiles. Once they send them down as SyncML, the client then processes the various configurations on the device, right? So there are components in Windows like similar to how group policy is processed today. MDM policies and apps or resources are also processed on the device and they're applied onto the device. And these are all done through these things called configuration service providers, CSPs, which are effectively just COM classes that serve as manageability APIs that, in terms of Microsoft, it lives in Windows. So all Windows devices have a common set of CSPs, which serve essentially as manageability APIs that MDM servers can then just call to manage things. So an example of this, there's an API that allows you to disable Bluetooth on a device, right? So if we work at Microsoft and I register my device with Microsoft, if they want to, they can call the CSP to configure Bluetooth and disable it on my device, right? Everything in yellow is covered under the MSMDE2 protocol, and everything in green is covered under the separate protocol called MSMDM, which deals with the ongoing management of a device. Are there any questions so far? If there are, feel free to just jump in anytime. We can make this an open discussion.
Why are these two different protocols there?
So the question is, why are these two different protocols?
I mean, I would have expected it to be just an MSMDM protocol for registering and so on.
So there are a lot of different ways to actually register a device with your organization.
Oh, that's okay.
So MSMDE2 covers more than just the pure MDM flow. So there's a lot of different ways to get it configured. So the MSMDE2 protocol talks about how to get all the different mechanisms and details like how those handshakes work. And the MSMDM, basically what it looks like is once you have the device enrolled, regardless of which path you took, there's then a common path to manage the device. So it's split into two protocols. Anything else at this point? Cool. So to understand the different types of MDM enrollment, there's really three broad categories, and I'm generalizing a little bit. But there's AAD join, adding a work account, and pure MDM enrollment, right? So you have three different main types of MDM enrollment. And to kind of break down what differentiates each of these types, it's important to understand the identity aspect of it. So going back to the example earlier, right? If I'm enrolling my device against Contoso's MDM, what happens is I'm just saying hey, here's a device, and you can manage the device. But if you think about it from the management server's perspective, they don't really have a good way of understanding who you are. Even if you enroll with, let's say, Tanvir at Microsoft, all they can say at best is, okay, great, that's an email address. I don't know what that means. So oftentimes what happens is management over MDM is tied with an identity system. In this case, because it's a cloud solution, it's usually tied with AAD, so Azure Active Directory. So some of these enrollment flows are often tied with, or they happen automatically when you register a device with AAD. So those two operations are kind of joined. And so you can see that some of the enrollment types like AAD join or adding a work account deal with also adding the identity at the same time. There's another distinction here that happens between user or device enrollments. And the best way to kind of understand this is if you look at Windows device, there's multiple users on that device, right? So I can have a user on the device, and Mamta can have a user on the device. And what happens is, as an MDM, if I enroll the device, then really the MDM so far just knows about me on that device, right? So it knows Tanvir is on this device. I know who Tanvir is because it's registered with AAD. I can look up this user and push down policies or configurations specifically for him, right? But then how does it know about other users on the device? Well, for certain types of enrollments, it actually doesn't know about other users on the device because the specific credentials or specific information sent up at the time of enrollment didn't include information about other users, right? So those are just specific user enrollments. There's another type of enrollment called the device enrollment, which when you register an entire device with MDM and AAD, what happens is then the MDM server says, okay, well, I just saw Mamta login, and I just looked up who Mamta was in AAD. I know who that is. And now I'm also going to push down policies specifically for her in addition to Tanvir's policies. So really a device enrollment is looking at how do you manage multiple users on the same device, right? or specifically target multiple users on the same device. So different variations of whether or not the identity is included or whether or not it's a user device enrollment make up this small matrix of how many types of MDM enrollment there are. Regardless of which one you want to use, there's a number of mechanisms to kick off MDM enrollment. So you can enroll a device through settings during the first run experience in Ubi. You can click on a deep link that's sent to you in an email or a website to enroll your device. You can use this feature called Windows Autopilot, which is a new feature. Basically what Autopilot is you register your device's hardware ID with an online service. And what happens at that point is once you register that device's ID with an online service, when you boot up the machine for the first time, like brand new out of the box, what will happen is the device will automatically configure itself and enroll itself against the MDM that you've chosen. So the experience is somewhat magical, right? You open the device brand new, it immediately says, hello Tanvir, it knows who you are, even though you've just purchased it and turned it on for the first time. You type in your work credentials because it knows where you're registered to work. So you type in your actual credentials and it just sets itself up. It takes about 2 minutes. And now your device is fully set up and personalized for you. So that's Windows Autopilot. There's these things called provisioning packages. So you use this tool called WCD, which is Windows Configuration Designer. And basically what this tool does is it allows you to kind of create this provisioning package, which is just a file that you can install either at Ubi or anytime during Windows runtime. And the provisioning package basically just contains instructions of what you want to do. So you can have commands in the provisioning package used to enroll a device. You can also disable Bluetooth. You can pretty much everything you can do with MDM, you can also do with a provisioning package. It's kind of like an offline way to stage a device or get the device set up before you hand it off to an employee or a student or something like that. And then there are also WinRT APIs that can also be used for MDM enrollment as well. So in the UX, what this looks like is you can go into settings, accounts, access work or school, and you click a button for connect. And you get this flow that kind of guides you through MDM enrollment. So you type in your username. If your organization wants to be secure and includes multi-factor auth, this is the point where you do multi-factor auth. And that's pretty much it, right? So the UX says you're done. You may have some additional policies coming down onto the device. So if you have things like apps that are being pushed from your organization onto your device, those may take time depending on your internet connection speed or where you are. But generally speaking, you see your MDM enrollment or your organization's connection show up on this page. And that's it. You register your device and the IT admin has pushed down all the policies they want to push down onto your device. So like in the UX, there's only like 2 or 3 screens total before the device is termed as MDM enrolled. But there's actually a number of things that happen to have that MDM enrollment take place. So this is what's covered under MSMDE2. When a user types in their email address, so I'll use my example of tanvir@microsoft.com, what happens is the client actually takes that email address, just takes the domain portion, so Microsoft.com, and prepends enterprise enrollment dot to it. And then it kind of pings this location, enterprise enrollment.microsoft.com. And it looks for this thing called a discovery payload. Now, discovery payload is just a simple XML. It contains 3 pieces of information that we'll need to enroll the device. The first piece of information it contains is this thing called an authentication service URL. What the auth service URL does is it basically gives the client the endpoint where the user actually has to type in their password to authenticate. So in the example, what will happen is I type in tanvir@microsoft.com. It looks up enterpriseenrollment.microsoft.com, finds that there is some endpoint for me to type in the rest of my Microsoft credentials, passes that URL back, and now the client loads that up, and I type in my password at that endpoint. Once I type in my password, and if I have MFA set up in my organization, I do my multi-factor auth. What happens is I get a token request, which is then passed into a device enrollment process on the client. What the device enrollment process does at this point is it looks at the other URLs that were included in the discovery payload that we got earlier. So specifically, it looks first at this URL called the Enrollment Policy Service URL. What this URL does is it gives an endpoint that the client can reach out to learn more about what type of hashing algorithms it needs to use to make the official enrollment request against the MDM server. So it reaches out to the Enrollment Policy Service URL and says, hey, like, are there any hashing algorithms, or which hashing algorithm should I use for my upcoming certificate request? And once it gets the information from here, it signs the certificate request and packages it up. It then calls this URL called the Enrollment Service URL. This URL was included in the discovery payload. And when we ping this endpoint, what we do is actually say, okay, well, here's a certificate request. It's packaged the way you've asked us to package it. Now, can I please have a enrollment certificate pushed down onto the device? Now, the MDM server at this point pushes down an enrollment certificate, which indicates the device is now managed. And for any subsequent interactions with the MDM server, we can now use this this enrollment certificate to prove that we have been enrolled or that we're a trusted source. What the MDM server also does initially at this stage is it also pushes down a very special initial set of policies to configure the device. So it configures things like, you know, how do you reach back out to me if you need to reach me at some point in the future? At what intervals should we be talking? So a polling schedule. Also, if there's any immediate type of policies, like a PIN policy or something along those lines, it'll configure that at the time of enrollment as well. And once this is complete, the device is now considered to be enrolled, right? So the device is now fully registered with MDM, and you know, it can be managed in the future. Now, for other types of enrollment, like AEDJ or the AED join or the adding a work account, what happens is the enrollment process is the same, but the actual authentication is handled on AAD. So you authenticate an AAD, and AAD passes down a token that we then feed into the device enrollment process, and the rest of the process is the same. So really the only difference between the various enrollment flows is how you get the initial token request and how discovery works. Because in AAD, the URLs that discovery generally pushes down, they're hard-coded and they're configured in AAD previously. So what happens is, as a user, I type in my credentials, and instead of going through the discovery process, I authenticate against AAD, and AAD knows how to push down a specific token and to provide the specific URLs that the client needs to continue the MDM enrollment process. So, you know, once I have my device enrolled, right, here's generally what the MDM lifecycle looks like. So to start, I need to be productive at work. So the MDM stack pushes down things like Wi-Fi. It pushes down PIN policies, certificates, and this is pretty much right after I enroll my device and I have it set up. And then if I need to be on the go at work, I get things pushed down like VPN. There's per app VPN functionality. Again, password for or hello for business. VPN integration comes down. It basically can configure my device so that I can take it and go on anywhere, really. My device and data are protected. So we have things like health attestation, which is a service that an MDM server can call a device and ask it to prove that it's healthy. So there's a service that runs alongside MDM that can be used to have a device attest to the fact that it is healthy. So you know if it's jailbroken or compromised or anything of that nature. And if it is, as an organization, you can choose to deny that device accesses to certain resources. So for example, if my device is compromised, or if my device is compromised or my antivirus definitions aren't up to date, as an organization, I can actually choose to have you not have access to things like SharePoint or other data that may be online. Let's see. There's also, actually going back, they can also push down things like Windows Information Protection. And what Windows Information Protection does is it helps me protect or classify and protect data on my device that belongs to me as an individual and data that belongs to an organization. So it helps classify based on which apps you use or which endpoints you're talking to, and a set of rules that IT has configured previously, whether data belongs to you or your organization. And it helps prevent things like, taking organization-owned data and moving it into a personal location or vice versa. So you'll actually get pop-ups in the OS that warn you when you're about to have data flow from one source to the other. There's services like Windows Update for Business, as well as there's policies around active hours and deployment, bandwidth optimization that help make sure that my device is current and up to date. And apps can be pushed down onto my device as well. So I mentioned earlier, so if I have a need to have Office on the device or Adobe Reader or some other LOB application like an app used for expenses, these can be pushed down onto the device using MDM. Beyond that, there's a number of options you can use to support the device. So you can remotely find or wipe the device. You can change the password remotely. You can remotely reboot the device. There's a number of things you can do to just help with the general support of a device. And then if I choose to leave this organization, my IT admin can actually remotely remove access from anything that's on the device as well. So it can choose to remotely remove all organization-owned data and get the device back into a state right before I had it registered with my organization. So the idea here is that you can kind of revert back to a clean state, if you will. The other important thing here is all data that belongs to the enterprise is removed at this time. Right, so if you do have sensitive information, you can rest assured that it will be removed. And finally, like, the process repeats, right? So you can, again, set up the device similar with the steps that I've outlined in the previous slide. That same device, if I take it to a new organization, I can again set it up for work, and the cycle can continue. So it's a general life cycle of how MDM works. You first enroll the device, and then there's a overall life cycle that follows kind of the stages of an employee as they go through an organization as well. For MDM sync sessions, what happens is, as a device, I've registered it with MDM. I've then, established this connection. I have a device certificate, but then how does this exactly work? So I have this managed device, and I have an MDM server. So what can happen is, first, the MDM server can actually push down a WNS push notification onto my device. And what will happen is the device will wake up and know that, okay, well, I just got pinged by an MDM server. I need to now wake up and reach back out to the MDM server to see if there are any updates or any policies or new payloads that I have to push down. And this communication happens over SyncML. Now, step one is actually optional. As I mentioned earlier, when the device is enrolled, one of the things you can configure is a polling schedule. So the client on its own, without having to have the server kind of push down that WNS push notification, it can actually wake up on a regular schedule and ping out to the MDM server and see if there are any updates or any new pieces of information that it needs to get on the device. And the way that the actual interactions work between client and server, you start the DM session, by sending out a very basic syncML to the server. Generally, this includes very basic device information, so it includes hardware identifiers and current state of the device. The server then replies back and tells you whether or not you have any updates. Generally, the way that any sort of MDM interaction works is the client will send up, the server will send down a set of instructions they want the client to kind of execute. And the client will respond back with a series of response codes corresponding to each of the actions the MDM server wanted to take. And then depending on those response codes, the MDM can choose to enforce additional policies, send additional commands, et cetera, et cetera. So a quick example of what this is, again, going back to the Bluetooth example. So the ability to configure Bluetooth is exposed via a CSP that allows you to configure Bluetooth. So the way you call a CSP is it's just a URI path that lives on Windows that you have to call using syncML. So an example path would be vendor, Microsoft, policy, connectivity, Bluetooth, right? And what you do is you set a value to a specific path, 0 for disable, 1 for enabled, for example. And so what will happen is the server will push down a command in syncML saying something like, for this URI path, set the value to 0. And the client, once it receives it, once it processes it, it'll actually reply back within the same sync session with a 200 OKs indicating that, hey, I've actually applied the policy correctly and Bluetooth is now disabled. And at this point, the server can continue to choose to enforce additional policies or not. But generally, that's how it works. And there's a lot of documentation around MDM or which specific CSPs are exposed in Windows as of the latest release in 1703 with the creators update. And as well as a lot of documentation around MDM enrollment in particular and the protocol documentation for MSMDE2 and MSMDM. And that is a brief overview of what MDM is and how to use it. Yes?
So as you introduce new CSPs, they don't get included in the documentation. They end up on the MSDN, right?
Right, so these links are actually to MSDN. So we update the docs with MSDN, but actually what we really do is we work very closely with all of the MDM server partners, and we give them a heads up, if you will, of here are the new CSPs that are coming in the upcoming release, and they build support for those CSPs in parallel to us. And so, for example, when we release the fall creators update sometime later this year, most MDM servers will announce support for those new CSPs within roughly 90 days.
Okay, thank you.
Mm-hmm.
Other questions? All
right. You went through this scenario where you talked about rolling a device against the MDM server, and you said you would register the device ID so that when you take the device out of the box, it will automatically register itself. I think that was the autopilot registration or something. Where'd you get the device ID from before you've powered up the device?
So we're working with OEM partners so that when they manufacture the device, they actually know to upload the device's ID into a backend service, which registers that device ID to the whoever purchased the device. So if I own Contoso, for example, and I ordered a bunch of devices, let's say Surface devices, what Surface will do is before they ship the device, when they manufacture it, they'll actually upload the device IDs to my portal. So as Contoso, when I log into my portal to see all the devices that I own, that device will actually show up. And when I see that device, I can choose to have that device enroll against my MDM or whatever. So that when now that it's registered in the background and it's already configured and linked, as an end user or my employee, when they open the device, it's already registered. So it knows that when it connects to Wi-Fi or whatever, to register against Contoso's MDM and set itself up.
Thank you.
Mm-hmm.
So as we configure these policies, most of them end up in the registry. So what's stopping someone going and modifying the registry manually?
That's a good question. So currently, there's not much that we can do to stop someone from editing the registry directly. That's a problem that we have even with group policy today. So there's kind of two mitigations to it today, which one, you can deploy the user as a standard user because all of these MDM policies and configurations are stored under HKLM. So as a standard user, you won't have the ability to actually edit those. But the other fallback is the polling schedule that I talked about that gets set up when the device is enrolled. So by default, the client will actually reach out to the MDM server every 8 hours. So even if you were to kind of change the registry key, it'll get reverted within 8 hours. So you do have a smaller window. There are a number of things we're doing that are in the pipeline for future releases to see what we can do to improve that process. Some ideas maybe around auditing or just improving the general security of it. But those are further in the pipeline and not what's in the product today.
Thank you.
Mm-hmm.
Other questions? Well, thank you. Thank you, Tanvir.
All right, thank you.